This is problem 31 from chapter 16. In this problem, we are to determine the distance the load W is lifted in 5 seconds using the hoist. The shaft of the motor M turns with an angular velocity of 100 times 4 plus t, where t is in seconds. So we want to find the distance that the load W is lifted, so let's call that delta SW, within 5 seconds, and they give us the angular velocity of the motor. So the angular velocity of the motor is the same as the angular velocity of pulley A, and if I find the speed of a point on the rim of pulley A, that's the same as the speed on the rim of pulley B. So let's write that as the speed for a point on the rim of pulley A is omega A times RA. This is the same as the speed of a point on the rim of pulley B, which is omega B times RB, and omega M is equal to omega A. Therefore, omega B is equal to omega M, which is the same as omega A, times RA over RB. And then B and C are turning together, so omega B is equal to omega C, and a point on the rim of pulley C is moving with the same speed as a point on the rim of pulley D. So we can say omega C times RC is equal to omega D times RD. And the angular velocity of E is the same as the angular velocity of D. And the weight is attached to this string, which is wrapped around E here. And so I can say the speed of the weight, that's VW, is equal to we can use the angular velocity of D because that's the same as the angular velocity of E, and whatever this radius is here, let's call that RE. So now we have our symbolic equations and we just have to plug numbers in. Maybe we can simplify it a little bit first. So omega D is equal to omega C times RC over RD. Omega C is equal to omega B, and omega B is equal to that. So we'll put this in here and then put it in here. So that gives us omega D is equal to omega C, which is equal to omega B, which is equal to omega M times RA over RB. That's the omega C, and then I have RC over RD, and then I can take this and put it in here. And finally, I have the velocity of W is equal to omega M times RA over RB times RC over RD times RE. And to figure out what direction it's moving in, you can take a look at the picture. It does say that the load is lifted, so it should be going upward. Okay, so now I have to go back to the picture to figure out what all their radiuses are. Omega M is 100 times 4 plus t. Then I have RA. RA is equal to 40 millimeters. RB is equal to 225. RC is equal to 30 millimeters. Our D is equal to 300 millimeters. And our E is equal to 50 millimeters. These cancel with these cancel with these. And that gives us 88.9 times 4 plus t. This is the velocity of W. I want to find delta SW at 5 seconds. So I guess going back to equation 12.1, where we have the velocity is ds dt, we can take that and rewrite it as ds is equal to v dt. Then we're going to integrate on both sides. On the left-hand side, that will give us delta S, W. On the right-hand side, we're going to go from 0 to 5 seconds. This is VW, which is 88.9, 4 plus t integrated with respect to t. When I do the integration, I get the 88.9 can come outside the integral. Integrating 4 with respect to t just gives me 4 times t. When I put in the limits of integration, that's 4 times 5 minus 0. So this is just 4 times 5 plus integrating t with respect to t gives me t squared over 2. When I put in the limits of integration, that's 5 squared divided by 2 minus 0. And finally, this gives me 2,889.25. I kept my units in up until this point here. So this was in millimeters per second. I guess I didn't put the units in for the angular velocity. This would have been in radians per second. So this would have been in millimeters per second. So delta S is in millimeters, so we can convert that to meters and call it 2.889 meters. And that is the distance that we were looking for. And that concludes problem 31.